both need to be tested and certified at some level. Could you both discuss how they differ? And I guess we could start with Sandy.
Sandy? With the people, and I know Michael will go into this a lot more detail, but with the people, we can always make mistakes as we're walking through our processes, as we're actually doing the testing. So that's definitely one piece that we need to look at, is who is doing that testing and how qualified they are. From the hardware, software, and process, I mean, you have documentation, you have an architecture, you can have experts and specialists walk through and, you know, what are the functions? Do the functions match up with the requirements? Yes, you need to have requirements, technical requirements. And what happens if I have an untrained user? What happens if I am a malicious user? What happens if I just want to go out there and have fun? So most of us internally do, with our quality assurance testing, we look at being a good user as we're testing hardware and software. We need to start looking also in that QA process with negative testing. What happens if putting those systems, the hardware, the software, and even the processes under load? Instead of having 1 or 2 operators, what happens if I have 50 operators all of a sudden giving commands? So we need to do a combination of the testing, good testing as well as the negative testing, but the people, finding qualified people, are definitely a separate type of test qualification than testing the hardware, software, and processes that somebody has. Michael?
Ooh, that's a good answer. I think using the component, or if you want to say software or hardware, usually it's more in the hardware world, IDF certification, I think there's the steps have a lot of overlap in that, as you eloquently spoke to requirements. Same thing with folks. I think there's a lot of hunger for that. I talked to a lot of folks working saying, well, what are the requirements for not only what I think my job is today, but where's it going and how do I develop myself? So help me define what this job is. And in many jobs, people just kind of, in security, we've seen this a lot when there's not a history or culture of security programs of, okay, your job is security. And someone goes, okay, whew, how do I start defining what that means? So this idea of starting with requirements and definitions, I can't see certification of individuals without proper development strategies, and obviously requirements of what tasks and skills you want them to have and where you think they need to be. Without it, then it makes no sense to conduct a measurement if you have no way to move them from where they probably are to where you want them to be. If you can't, once you define that, I think that's very critical. And when I think of certification and testing and measurement instruments, much like hardware and software, it's a process, meaning I'd like to see assessment instruments so that an individual knows where they are in their skills, and then you could look and actually not just measure the individual, but measure your development program. How far did we accelerate them from this point where they were to where they need to be? And that's, so testing, when I think about testing, it's pre-certification, figure out, did I develop them the way we need to develop them? If the answer was yes, and then you have this reasonable confidence that that's what we want, then you could certify individuals at some point. And again, I think in a lot of regimes, we can't rush to an achievement test type approach to certification. It's not, here's the body of knowledge you need to know, go study it and regurgitate it, and if you have that, then we'll certify you. It's aptitude, and that's an area that I think we need to get into with the people side of the business. Eventually, I think it's a proactive opportunity with smart grid for utilities. One thing I struggled with when Section 215 was written, it's a very clear law. It's a couple pages long, but it established an electric reliability organization and that was responsible for reliability and cybersecurity, which is a pretty profound concept, that it called out cybersecurity in the law and made the ERO responsible for both. But if you looked at the ERO programs, NERC's programs weren't balanced in those two domains. So for example, we had a mandatory grid operator certification for control system, for dispatch center and transmission operations, reliability coordinators. And it's still an achievement-based examination, but it was a requirement or a standard to benchmark. We never had anything like that around cybersecurity. We didn't know what to ask of the people. So I think the people part follows a lot of the same process as the hardware and software, but I think your goal there, you don't want to rigorously be beating people up. I was in the Navy, we did that. You want to help make sure part of that whole program is set up to develop them through, meaning you move them through. And sometimes you want to do that with software and hardware. You're in the development stage, you do your own testing to try to get it to the place for performance where you want it to be. You got to approach people the same way.
Now, you had also mentioned testing and certification in the same sentence. Do they mean the same thing?
I don't think so. The key to certification is that you arbitrarily set a target around the threshold of where a device needs to be. And why I said they're different is I think you can use measurement instruments like testing to determine where someone is for different purposes. You will eventually find value potentially, in this case of saying a certification threshold's here, so it's got to get over that bar. Sometimes it's hard to do that with people, and sometimes for people in particular, where machines, it's deterministic. There's usually one path to achieve that performance goal. Sometimes with technology, you can have different branches to achieve an outcome. But with people, there's usually multiple paths. So I'll give you a very quick example for security testing. I've seen different flavors of security testers, some that are very tool and method oriented, so they're very process-oriented people, and others that are far more creative minds, more artistic in the way they look at problems, and they try to think about where there are limits and boundaries not being explored. Both are successful paths to get to an outcome that says, am I exploring the technology in a way where I'm understanding risk? So, sometimes people have a lot more paths, so it's harder to hit those thresholds to do a certification sometimes, but you can do it.
Great, well, thank you very much. That's excellent answer, both of you. I got to ask this, and I sort of know the answer, but I want to hear from you. Does the extremely dynamic nature of security create an environment where testing and certification standards are not only difficult to establish, but maybe sometimes even potentially detrimental, depending on how rigid they may be? And maybe I could start with you, Sandy?
Oh, thanks. Doesn't always have to be ladies first. From the cybersecurity testing, until there are good actionable requirements to be able to set up testing and certification, that's just a flat-out hard one to answer. To get certified and accredited, anybody can perform security tests. But unless you have the specific requirements in what you're testing to as a goal, actionable, I can interpret this requirement in one and only one way. I have an outcome that I want to achieve. Cybersecurity testing is still going to be in that influx until there's a good set of the requirements. And I'm not saying a test plan, and this is how we test it all the same, but a good same end game with the cybersecurity side.
It's a great question because testing in a security context, in an operational context for devices, and I'm very familiar with in the nuclear world, we tested hardware. You had performance targets or performance or a design performance that were not going to change. You needed the device to hit a certain level. You need to have a failure rate at a certain level, and that was just inherent as targets that we didn't expect. The understanding of risk of why we'd change the target, that might change in a different application for a piece of hardware, and then you're going to design a different performance target. For security, we constantly move it, and the analogy is a design basis threat we use in the physical security world around nuclear power plants, as an example, or the nuclear complex. We sit there and say, well, we have a desired performance target, and we are going to certify nuclear power plant security forces to that target. But guess what? It's very painful when it happens, but that target continues to change as we sit there and give the adversary more capability, or we have a growing understanding of what the adversary is capable of, or they change their tactics and techniques and demonstrate something that says, oh, didn't think about that. We thought about, in one simple context, high explosives, and then all of a sudden when you add the physics of doing what's called a flyer plate, so it's high explosive pushing a big piece of metal very fast, then you sit there and say, whoa, that can compromise material in a way that we didn't think, so let's give the bad guys that capability, and now we're going to move the desired targets of the security force into a different place. And so that's the danger for setting targets, is if you don't have a way to manage that change, to go out there and ground truth, what our concerns are, and move that through the life cycle, then you set false expectations, you set a bar and say, there's the desired target. Everyone engineers to that. And then you get this unfortunate place where you've got a lot of stranded investment because everyone's engineered to this target, and guess what? I just moved it up here and said, well, no, it's not just that. We're worried not only about firmware leaving the device and being modified, but we're worried about this element of it because now people have demonstrated that. And unfortunately, that's very hard to engineer into a process. But if you go into it knowing that that's how it's going to work, you could maybe design a process that's a little smarter. What we have to be careful of is to set a static requirement that later we find not useful, but we spend a lot of money getting there and proving it. That's where we have to avoid.
And then find the weakness in that to move it forward.
Great, thank you. So, we are definitely making some progress, I know for sure in NIST, in determining testing and certification criteria for the smart grid. Can you share with the audience the progress that's being made and, where you see us moving? And then, afterwards, Mike, we could, of course, talk about, some of the progress you've been making in your...
Yeah, I'm not commenting on this progress. I did that once at a FERC conference.
Within the NIST SGIP, there is a testing and certification committee, and it is based upon interoperability. They have developed an interoperability process reference manual, IPRM, as a lot of people may have heard, where it is a model of what they are trying to get labs to conform to. They are also basing a lot of their information on ISO 17025 and ISO Guide 65, which if you've read those are very generic guides. They don't get into detail of how you set up your environment. But they're building the foundation. They are also looking at a lab qualification manual to help utilities look for specific testing labs from interoperability. And right now I'm still just talking interoperability. They are looking for interoperability test and certification authorities, where this is going to be a group of companies, bodies that will certify labs to the interoperability process reference manual, as well as looking at their ISO 17025 and ISO Guide 65 certifications. So they are trying to set up a certification for interoperability at the smart grid level. They are looking at a couple of the standards bodies to help us put that together and move that forward. Now, to take it one level down within the CSWG, we have the testing and certification subgroup where we are focusing specifically on cybersecurity testing. And what we have done is taken the NIST IR 7628 and looked at it from, are these requirements actionable? Meaning, can I get an outcome or test to this requirement? And testing means examine documents, examine systems, perform interviews, or perform an actual test, and that this requirement is interpreted, can be interpreted only one way. So we've made an initial pass, and when the high-level requirements group starts up in the summer, we'll help make recommendations to tighten up some of those requirements. Also within the testing and certification subgroup, we've gotten together a brainstorm list of security labs. Right now it's US focused, not internationally focused. We are also looking at building some use cases, security use cases that will help test the various security services that are out there, building requirements in there. We have also taken the SG Security AMI Security Profile document and started looking at that and seeing whether or not those are actionable so that we can kind of set up guidelines for somebody that wants to take a set of requirements and see if they're testable. As another task, we are also trying to build an RFP type guidance document so that as utilities are going out and doing cybersecurity testing, here are some basic questions, not necessarily basic questions, but a list of questions of if you want the full-blown engagement, here are some questions you can ask, all the way down to, I just need some testing done, so for a smaller muni co-op, we're also setting up requirements for them of how they can talk to various security vendors and do the testing. All of the cybersecurity testing and certification subgroup output and work is all going to roll up to the testing and certification committee. So their output is both interoperability as well as cybersecurity testing. And we all know that many times when you do cybersecurity testing and cyber improvements, it kind of breaks the interoperability. So that's why we're trying to work both groups together so that as the programs move forward, we have a good, solid product moving forward.